All right, page 114. Today we're going to be solving rational equations. Solving rational equations. So far we have simplified rational expressions. We've multiplied rational expressions. We've divided rational expressions. We've added and subtracted rational expressions. But nothing has had an equal sign in it, right? We haven't done anything with equations. Well, today I'm going to show you what to do when you have a rational equation. The thing about rational equations is, though, that it's possible that your answer, you did your math correctly, but the answer doesn't work out right. Does anybody remember what that's called when that happens? What kind of solution that is? Not close. Extraneous, right? So extraneous is when you get an answer, and the answer is right because of your math, but when you plug it in, it doesn't work, okay? So the thing about these is you have to check your work, because if an answer is extraneous, but you list it as an answer, it's wrong, all right? And it's kind of a pain, but it's worth it, especially on a test or FSA, all right? So a rational equation contains at least one rational expression you can simplify a rational equation if you first clear the equation of denominators. You can do this by multiplying the least common denominator of the rational expressions in the equation. When solving rational equations, it is possible to get extraneous solutions. You must check the solutions in the original equation for extraneous solutions. You must check all solutions in the original equation for extraneous solutions. Okay, so we have a rational equation because we have rational expressions and there's an equal sign. So we have to figure out how to solve for x. And there's a whole lot of stuff going on, right? So currently our denominators are x minus 3, x plus 3, and x squared minus 9. Sometimes you're going to have denominators that can be factored. Sometimes they're going to be completely factored. It just depends. It's nice when everything's already factored. Are all of our denominators completely factored? No, because this is a difference of two squares, right? So we could factor that further. Is x minus 3 completely factored? And x plus 3 is completely factored, right? X squared minus 9 is not. So I'm going to rewrite this. I know you can do this a little shorter when you do your homework, but of course in my notes I want to show every step so you can easily follow. And what is x squared minus 9 going to factor into? X plus 3 and x minus 3. So once it's completely factored, we will figure out what our least common denominator is, which basically is the same thing that we were doing when we were adding and subtracting fractions to make equivalent fractions, right? We had to make sure one of our factors was taken into account, one of each of the factors was taken into account for the least common denominator. So give me one of my factors in my LCD. X minus 3 and x plus 3. Anything else? No. All right. So to clear the fractions, and this works if you have any kind of fractions. If you multiply every single fraction in the whole equation by the least common denominator, you'll get rid of the fractions. All right? We call it clearing the fractions. If you know how to do it, it makes problems a lot easier that contain fractions. Okay. What I write on my next line is going to look super long, but I don't know what to tell you. It just is. You could probably shorten it a little in your homework. Okay, so I'm going to multiply this fraction by x minus 3 times x plus 3. I'm going to multiply this fraction by x minus 3 times x plus 3. I'm going to multiply this fraction by x minus 3 times x plus 3. Okay? It's really not that much work. Writing it is the most work. So I'm going to write this first. So I'm going to say x minus 3 times x plus 3. If I wanted to turn that into a fraction, I could put it over a 1, right? Which you don't have to do, but, and I'm multiplying that by x times x minus 3. Should have used like a red. Plus, I'm going to multiply this fraction by x minus 3 times x plus 3. And then I will equals, I multiply my last fraction by x minus 3 times x plus 3. Now remember when I taught y'all how to simplify, or I'm sorry, to multiply these rational expressions, how we can reduce out factors that are identical, right? But like I couldn't reduce this x minus 3 from this fraction here with this x minus 3 over here, because I'm not multiplying this fraction times this fraction, okay? I'm multiplying these two together, plus I'm multiplying these two together, equals I'm multiplying these two together. So I can only reduce within the two fractions that I'm multiplying at a time. All right? So let's look at my first fraction. Can I reduce anything or cancel any factors in just the first fraction? X minus 3. Plus, in my second fraction, what can I reduce? X plus 3. Equals, in the next one, what can I reduce? x minus 3, and x plus 3. So that's a whole lot of multiplying that we're not actually going to have to do, right? So now I'm going to go and rewrite everything that's left. I should not have anything left in the denominator except for a 1. And of course, we don't have to write a 1 if that's all that we have. So in my first fraction, I have x plus 3 times x. I like to write the monomial first. You could go ahead and distribute if you want to. I'm not going to because I'm going to show my steps. And then we have a plus sign. Everything's canceled except for x times x minus 3 equals, in my last fraction, everything canceled except for just the 2. Doesn't that look like a whole lot easier than what we started with? No fractions, right? Okay, so now I'm just going to distribute, see what I have, and see what I can do to solve for x. Am I going too fast? Too slow? Just right. Alright, so x times x is x squared. X times positive 3 is positive 3x. Positive x times x is positive x squared. Positive x times negative 3 is negative 3x equals 2. Now if I'm solving for x, what do y'all think I should do? Combine like terms, set equal to 0, and put in standard form. And then hopefully we can factor it and then set our factors equal to 0 to solve, right? If not, we can see it's going to be a quadratic, and we could use quadratic formula or completing the square, but let's just see what we have. Okay, so I have two quadratic terms. What is x squared plus x squared? 2x squared, I'm so proud. 3x minus 3x. What? Cancel out, make 0, right? And that equals 2. Now, if I'm solving for 0 in this problem, is it going to be necessary to subtract the 2 from both sides? Or can I just solve for x like it is? Because that's what I'm trying to do, right? I'm not trying to factor, I'm trying to solve. So normally, if I had a linear term, if my linear terms didn't cancel out, I would bring that 2 over and then see if I could factor it. But since I'm just solving and I don't have a linear term, I could just go ahead and divide by 2 and get x squared equals 1. And then what? Square root both sides. Make sure 2 degrees is 2 solutions, right? So I have to take the positive and negative square root of 1. So x equals what? Positive and negative 1. Now remember earlier we wrote that you had to check for extraneous solutions, and that is kind of a pain. But you have to.
Even when it works out? Even when it works out like that?
Yeah. Because when we say we plug in negative 1 up here and it makes a false statement. But if we didn't check it and negative 1 is extraneous, but we said it's a solution, we're going to get it wrong. Well, so like especially on the FSA, because you need every point that you can get, you need to take the time to check it. All right? Now, I'm going to, at the beginning, I'm just going to plug it in, and then I'm going to try to do some calculator work to save a little bit of time. Let me see if I can fit it on this portion of the page. And I may be able to since I'm going to use my calculator. So I'm going to check the positive 1 first. X equals 1. So I'm going to plug that in to my original equation. So wherever I see an x, I'm going to plug in a 1. So that's 1 over, what's 1 minus 3? Negative 2 plus 1 over 1 plus 3 is 4 equals 2 over, what is 1 squared? And 1 minus 9? Negative 8. Okay, so let's just do some fractions here. Negative 1/2 is the same thing as negative 0.5 plus 1/4 is 0.25. 2 over negative 8, that's negative 2/8, which is negative 1/4, which is negative 0.25, right?
Yes.
Can we see that's true, or should I put it in my calculator? We can see it's true, right? But JIC, 0.5 negative plus 0.25 equals negative 0.25. Okay, so 1 is a solution for sure. Now let me just check negative 1. Hopefully you have this on calculator day. If not, you have to work it all by hand, which I always do notes before I give my notes to all my classes. So I did this by hand with all fractions, which I didn't use a calculator on. So if you don't, you're going to have to do it like that. Okay? But it's fractions. Third grade. You got this. Probably calculator day. So let me plug in a negative 1. So that's going to be negative 1 over, what's negative 1 minus 3? Negative 4 plus negative 1 over negative 1 plus 3 is 2 equals 2 over. Now negative 1 quantity squared, so positive 1 minus 9 is negative 8. All right, over here, negative 1 divided by negative 4, that's a positive. I'm going to change it to a decimal, so positive 0.25. Negative 1/2 is negative 0.5, so plus a negative 0.5. I'm just going to put minus 0.5 equals negative 1/4, which is negative 0.25. Is that a true statement? 25 cents minus 50 cents is a negative 25 cents. So they are both solutions. But I'm telling you, you're going to have extraneous solutions often. Maybe not often, but it's going to happen. And I would hate to do all that work perfectly and one of them be extraneous and you get it wrong because you didn't check it. You know what I mean? I'm not sure that they'll ever both be extraneous. I don't think that could happen. I don't want to say 100%, but I don't think they would both be extraneous. But all right, everybody good here? All right, page 115. X minus 1 over x plus 2 equals x squared plus 2x minus 3 divided by x plus 2. Now I can actually do this problem two ways. All right. Since it's just a fraction equal to a fraction, think of that like a proportion where you could find the cross products. On the last one we couldn't do that because on the left side we were adding two fractions together and it said equal to a fraction. But when you have a fraction equal to a fraction, you can either find the cross products. Y'all like to call it cross multiply, but those aren't technical math words. Like FOIL's not a technical math word. It's technically called find the cross products. You can do that if it's two fractions that equal to each other. Or you can multiply both fractions by the least common denominator. I'm going to do both of them here just for our notes. Obviously in your homework you pick which way you want to do it. But before I do that, I can see that my denominators are both factored completely, right? But this numerator can probably be factored further. And I'm going to go ahead and do that so I can probably cancel out some factors. Alright, so I'll do that over on the side. X squared plus 2x minus 3, quadratic. Now, I've had several new students in the last couple of days. You may have learned factoring. You probably learned it different than the way I teach it. So if you want to factor this using your own method, I'm totally cool with that. This is just how I do it, okay? So we need two numbers that multiply together to give us whatever a times c is, so that's a negative 3, and that add together to give me whatever b is, which is a positive 2. Negative 1 times positive 3 equals negative 3. And negative 1 plus 3 equals positive 2. So that works, right? Am I going to have to divide and slide? No, because A is 1. So my factors are x minus 1 and x plus 3. Now, first I'm going to do it just by multiplying every fraction by the least common denominator, which my least common denominator is what? Just x plus 2. So I'll multiply this fraction by x plus 2, and I'll multiply this fraction by x plus 2. Obviously, these are going to cancel, and these are going to cancel. And then I'm left with x minus 1 equals x minus 1 times x plus 3. Remember, I'm trying to solve for x, not just factor. Trying to solve for x. So, what do you think I should do now? I should FOIL this, because I can't bring this stuff, the x minus 1, over here until I get this, rid of those parentheses, right? So, that's going to be, I'm going to distribute, x times x is x squared, x times positive 3 is positive 3x, negative 1 times x is negative x, negative 1 times positive 3 is negative 3. I can move this stuff over now, but I'm going to wait until I get these like terms combined, because a positive 3x minus x is a positive 2x. And now I can get it set equal to 0 and put in standard form. So I'll subtract x from both sides, and I'll add 1 to both sides. Notice I'm putting it under its like term. So I get 0 equals x squared. 2x minus x is positive x, and negative 3 plus 1 is negative 2. I have not solved for x yet. Hopefully this is factorable, and I can factor and set each factor equal to 0. If not, I'm going to use quadratic formula or completing the square, right? This stuff we know. So over on the side, let me try to factor x squared plus x minus 2. A is 1, B is 1, C is negative 2. So I need two numbers that multiply together to give me A times C, which is 1 times negative 2 is negative 2, and add together to give me B, which is positive 1. 2 times negative 1 is negative 2. 2 plus negative 1 is positive 1. So that works. So that's going to be x plus 2 and x minus 1. Do I need to divide and slide? Nope, because A is a 1. Okay, so now I can just set each factor equal to 0. And solve for x. So according to the math that we did, which we did correctly, our solutions are negative 2 and positive 1. But we could have an extraneous, right? So let me check that over to the side. Going to check x equals negative 2 first. Slide this down so I could see. And really, these two equations, before I cancel anything, when I factored here, it is identical to x squared plus 2x minus 3. So I'm going to plug it in there just because to me the factors are easier than that quadratic, okay? So when I plug in, what's negative 2 minus 1? Negative 3 over negative 2 plus 2 is 0 equals, can you have 0 in the denominator? No? Okay, so probably this is not going to work. And then on the right side, negative 2 minus 1 is negative 3 times negative 2 plus 3. It's 1 over negative 2 plus 2, 0. You know how when we did our restrictions, if we looked at this, what can x not equal? Negative 2. That was one of our solutions. Can't be negative 2, right? And we just saw when we checked, that gives us a 0 in the denominator. So negative 2 is not a solution. So this is extraneous. You cannot list it as a solution because it's not. Mathematically it worked out, but when we plugged it in, it made a false statement. Alright, let's check x equals 1.
So we still have to check it even though we already found it's not 100%?
This isn't, but we got to check this one. Because maybe they both aren't. I don't think that can happen, but maybe it can. I don't know. So, I don't want to be wrong and tell you that it never can, and it happened. Alright? So, plug this back in to here. Let's see if I can see both on my page. Alright, so 1 minus 1 is 0. Can I have 0 in the numerator? Yeah. Over 1 plus 2 is 3 equals 1 minus 1 is 0 times 1 plus 3 is 4 over 1 plus 2 is 3. 0 divided by 3 is 0. 0 times 4 is 0. 0 divided by 3 is 0. Is that a true statement? Yes. So my only solution is x equals 1. Now let me show you how to do it if you just cross multiply. To me, I guess you're pretty much doing the same amount of work, but to me, I just like to clear the fractions. It's easier. But I'm going to do the same problem on the next page by using cross products. I said cross multiply. Bad. Using cross products instead of clearing the fractions. Everybody cool with this one? Okay. Same problem. Now, if I'm going to use this method, I probably would not factor that numerator. Because when I do the cross product, I'm going to multiply x plus 2 times x squared plus 2x minus 3. If I factor that out, I'm going to have a whole lot more distributing going on than if I don't factor it out. Okay? You can, but you're just creating more work for yourself. And then I'm going to find the cross product of x minus 1 times x plus 2. And that's why y'all say cross multiply, but it's find the cross product. Okay? So I'm going to say x minus 1 times x plus 2 equals x plus 2 times x squared, bless you, plus 2x minus 3. So basically I'm going to distribute the left side, get it simplified, distribute the right side, get it simplified, and then get everything moved to one side of the equation and hope that it can be factored. Everybody cool? Okay, so I'm just going to FOIL the left side real quick. We know how to do that. First times first is x squared outer times outer, plus 2x, inner times inner, minus x, last times last is minus 2, which gives me x squared plus x minus 2. On the left side, I'm going to have to distribute x times every term in the second set of parentheses, and then I'm going to distribute 2 times every term in the second set of parentheses. Okay? So x times x squared is what? X cubed. X times positive 2x is positive 2x squared. X times negative 3 is negative 3x. Now I'll move along to my 2. 2 times x squared is plus 2x squared. Positive 2 times 2x is positive 4x. Positive 2 times negative 3 is negative 6. So simplified, I have x cubed. 2x squared plus 2x squared is plus 4x squared. Negative 3x and plus 4x is plus x. And then minus 6. Okay, now I'm going to move everything to one side. So I'm going to subtract x squared. I'm going to subtract x. And I'm going to add 2. So 0 equals x cubed plus 3x squared minus 4. Did I make a mistake anywhere?
No.
Because on this problem, is there a GCF? No. Can we factor by grouping? No. Is it some sort of special case that we know about? No. Can we do a quadratic formula? Not a quadratic, right? Can we use completing the square? Nope, we can only use that on quadratics. There is a way we could factor this. We could test certain factors with division, but we haven't learned how to do that yet. So what we know how to do right now, we don't know how to finish this problem from what we've learned. All right, so this method on this particular problem, I wouldn't use it because in the end, it's solvable. We know it's solvable because we used it the other way. I would use this method when you have easier problems. Like if I had, let me just write this. Woo! Like if I had 4 over x equals x over 4. I would use it on a problem like that. 4 times 4 is 16. X times x is x squared. What is x equal to? Just 4? Positive or negative 4, right? Because we would do the positive negative square root. So a problem like that, I would just use the cross products. But one like this where you have all these polynomials, because in the end, maybe we did get to a problem that we could factor easy or use a quadratic formula. But we haven't learned yet every possible way to factor, especially when our degrees are higher than 2. So sometimes it's easier just to use the other method. Sometimes it's not, so it kind of just depends on the problem. Okay? When we get to one that will work out easier, I'll show you again. Okay, let's look at another one where we're going to clear the fractions on. X over or divided by x plus 1 plus 3 divided by x plus 4 equals x plus 3 over x plus 4. Y'all see that? Okay, on this one, could we use cross products?
No.
No, we can't, because it's not a fraction set equal to a fraction. If it looked like that, we could. All right? So does anything need to be factored? No, so this is going to be super easy. What's my least common denominator? X plus 1 and x plus 4. So I'll multiply all three of these fractions by x plus 1 and x plus 4. We good? Okay, so my first fraction, x plus 1 and x plus 1 reduce, plus, and my second product here, x plus 4 and x plus 4 reduce. And then on the right side of the parentheses, x plus 4 and x plus 4 reduce. All right? So here we have what's left. We have x times x plus 4 plus, again, I like to put my monomial first, 3 times x plus 1 equals x plus 1 times x plus 3. I'll clean it up. I'm going to distribute x squared plus 4x plus 3x plus 3 equals x squared plus 3x plus 1x plus 3. Now I got to get all that simplified and all to one side of the equation or the other and see what we have going on. So I'm just going to combine like terms on the left side and combine like terms on the right side, and then I'll move everything over. Okay? So on the left side, I've got x squared plus 4x and plus 3x make plus 7x plus 3 equal. On the right side, x squared plus 3x plus 1x is plus 4x plus 3. Now, it really doesn't matter if I move the x squared over to the left or over to the right, because what's going to happen to the x squares? They're going to cancel, right? So if I move x squared over, then I'll just try to move everything to the left because my next term would be linear. And if I move this over here, it will be a positive. So I'm just going to do that. But it really doesn't matter. So I'll subtract 4x from both sides. And I'll subtract 3 from both sides. Everybody cool with that? So x squared minus x squared is 0. 7x minus 4x is 3x. Positive 3 minus 3 is 0. And then on the right side, everything canceled. So what am I going to do? Divide by 3. And x equals 0. This time I only have one solution. Is that okay?
Mm-hmm.
Yeah, can 0 be a solution?
Yeah.
Yeah, am I still going to have to check it? Yeah, because maybe this thing has no solution, right? So let me do that over here. So I have 0 over 0 plus 1 is 1, plus 3 over 0 plus 4 is 4, equals 0 plus 3 is 3, 0 plus 4 is 4. What's 0 divided by 1? 0. So basically I have 3/4 equals 3/4. True statement? Yes. Is 3/4 my answer? No, 0 is my answer. Everybody cool with that?
Yes.
Anybody need me to wait? Easy, right? All right, I'm almost finished. Wait, this is a fraction set equal to fraction. So I could do one of two things. I could find the cross products and go that route, or I could clear the fractions. On this one, I am going to show you both, and it will work out this time where you can see how that either method will work for what we know how to do. First, I'm going to clear the fractions, though. So what's my least common denominator? Does anything need to be factored?
No.
No. Okay. What's my least common denominator? X minus 2. So I only have these two fractions, so I'll multiply them both by x minus 2. Reduce what I can. And then write what I'm left with. So I have, on the left side I just have 4 equals, on the right side, x minus 1. Is that going to be difficult to solve for x? No. How many solutions are we going to have? One. Well, we'll have to check it, but right now it looks like we'll have one. So we will just add 1 to both sides. And according to our answer, x equals 5. And check it over here on the side. So if I have 4 over 5 minus 2 is 3 equals, what's 5 minus 1 over 5 minus 2? 3. True statement, right?
Yeah.
So our solution's x equals 5. Now let's do the cross product. Same problem. So if I'm doing the cross product, I'm going to do 4 times. Make sure you put parentheses around the x minus 2 because you're going to have to distribute. Equals, don't forget the equal sign. You're not just making one big expression. You have to put the equal sign. It's a common problem that I see students make. And then x minus 2 times x minus 1. Again, I'm going to put parentheses around both of those binomials. To me, this is just more work. Depending on the problem, you make the decision. So on the left side, I'll distribute 4x minus 8 equals. On the right side, I'm going to distribute or FOIL. We get x squared minus x minus 2x plus 2. I'm going to go ahead and combine like terms before I start bringing stuff over. We get x squared minus 3x plus 2. And then since my highest degree is on the right side, I'm just going to bring everything over to the right side. So I'll subtract 4x, and I will add 8. So I'm left with 0 equals x squared minus 7x plus 10. But I haven't solved anything yet. It's a quadratic, which means I'm going to get 2 solutions, but in the last one I only got 1 solution. So is that weird?
One of them's going to be extreme.
One of them's going to be extraneous, right? So let me try to factor this. A would be 1, B is negative 7, C is 10. Two numbers that multiply together to get A times C is a positive 10. And then add together to get B, which is negative 7. Negative 5 times negative 2 is positive 10. And negative 5 plus negative 2 is negative 7. So 0 equals x minus 5 and x minus 2. Do I need to divide and slide? Nope, because A is a 1. So set each factor equal to 0. Add 5, x equals 5. Add 2, x equals 2. How do we already know that 2 can't be a solution? Because we did check before, but we didn't check the 2. We didn't plug in a 2.
So I have one solution.
It did, but look at our problem.
Because there's only 1 degree. The highest is just 1 degree.
True, but what else?
X can't equal 2 because they'll cancel out.
Right, our exemption, right? If we plug 2 in the denominator, 2 minus 2 is 0. Can't have that. 2 minus 2 is 0. So just knowing that right there, we know without even checking the 2, it's not going to work because it's going to give us a 0 in the denominator. So 2 is extraneous. So even just thinking about that, what your exemptions are, will help you. So our only solution, again, as we saw above, is 5. Let's do one more. It's an easy one. Sometimes I forget to do the easy ones in the notes, and then you see it in the homework, and you're like, whoa, we didn't do all this. Because I just assume because it's easier than the ones that we did. So let's throw an easy one in there. Page 118. Is everybody finished with this page? Divided by 2x minus 5 divided by 3x equals 2. What's 2's denominator? 1. Okay, do we have to include that in the LCD? No. Can we use the cross product method on this? No, because that's not a fraction set equal to a fraction. If this was our problem, we could use cross product because we could do the 2 into a 1 and do the cross product, okay? But it's not, so we don't have to worry about that. What's my least common denominator? 2x and 3x. You could do that, but that's not my least common denominator.
1.
How about 6x? Does 2x go into 6x evenly? Does 3x go into 6x evenly? Okay, or if you thought about it like this. My prime factors here. This 2x, isn't that 2 times x, right? And 3x is 3 times x, but we already have an x, right? So we don't need another one. So 2 times x times 3 is 6x. If you just want to write it, if you wanted to do 2x and 3x times all of these, that's fine. You're just going to have more reducing. It's not the least common denominator. All right?
So you do 6x times 3 over 2x.
And then we'll just have to reduce. But it will clear the fraction.
Could you not subtract them first and then... Okay, I got you.
You got me? You could subtract them first and go that route, but probably cause you more work. Okay? So if you wanted to think about it, let me just show you. So I'm going to say 6x, we'll put over 1, times 3 over 2x minus 6x over 1 times 5 over 3x equals 6x, and I'm not going to put it over 1 since 2 is not a fraction. And you're thinking, whoa, 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 those don't cancel. Okay, they don't right now, but we'll be able to reduce, and that will clear the fraction. So remember, when you're multiplying fractions, you do numerator times numerator, denominator times denominator. This is not a cross product because there's no equal sign between them, right? So what is 6x times 3? 18x divided by 1 times 2x is 2x minus 6x times 5, 30x over 1 times 3x is equals 6x times 2, 12x. But they're still fractions. Well, let's see if we can reduce. If you can't reduce, then something's wrong. You picked the wrong least common denominator. Okay? As long as your least common denominator is correct, or it's at least a common denominator, then you should be able to reduce and the fractions will go away. All right, 18 divided by 2 is, and x divided by x is 1. So basically, 18x divided by 2x is 9. Minus, what's 30x divided by 3x? 10. Equals 12x. This looks like we're going to get a fraction. Is that okay? Yeah. Can you get a fraction? It's 9 minus 10.
-1.
-1 equals 12x divided by 12. X equals -112. And that's going to be fun to check. And if I turn it into a decimal, it's repeating. All right, well, I'm just going to try and do most of this by hand. All right, so we have 3 times, this will be a good little practice in all our fraction stuff. 3 divided by 2 times -112 minus 5 divided by 3 times -112 equals 2. All right, so 3 over 2 times -112. Okay, so multiplying fractions, 2 times -1 is -2. 1 times 12 is 12, right? Minus 5 over, that would be 3 times -1 is -3. 1 times 12 is 12. Okay, 2/12. Let's see if we can do some decimal here. That's also repeating, so I don't want to do that. So we have 3 divided by, that's -1/6 minus 5 divided by -1/4 equals 2. Now let me do some decimal work and just see if it's really, really close. Okay. So 3 divided by, I'm going to use parentheses, -1 divided by 6 is, oh, well, that worked out okay. So let me just make sure I did it right. 3 divided by -1/6 is -18 minus 5 divided by, open parentheses, -1/4. And that's, I'm subtracting a -20, right? Equals 2. So that's -18 plus 20 equals 2. 2 equals 2. True story. So that's my solution. Checking is sometimes more difficult than the problem. We all good? Think you can tackle your homework? Have any questions? All right. So I will be putting the video on Edmodo if you need to review. Or if you have any absent friends, let them know. I'm no longer putting just the blank notes on there. So if people are absent, if they want to get the notes, they actually have to watch the video, which is good because it's like they're making up missed class time, right? And it's easier to understand when you hear it and see it than just looking at the paper. So, okay. Why is this stopping?